Hello friends, welcome to engineering tutorial. So today we are going to start a new topic which will be thermodynamics. So the next series of videos will be on this topic. So the first video, which will be a basic introduction to the whole concept, the whole series, and will be starting with the concept of heat. Okay, so before we discuss heat, let us first see two situations. Suppose we stand near a log of fire. What do we feel? We feel warm on a winter day or a wintry chilly night. We stand near a log of fire. We get warmth, and during summers, let's say we open the refrigerator, the door of the refrigerator, and we put our hand inside. We feel a sensation of cold, we feel cool. So why does that happen? What is responsible for that sensation of hotness and coldness, that warmth and that the sensation of cool, that cold that we feel? So the answer to that question is heat, the flow of heat in one direction or the other. Okay, so heat basically, it is a form of energy which produces in us, that is in the human body, the sensation of hotness or coldness. When we put our hand close to the fire, we feel a sensation of hotness, and when we put our hand in the deep freezer, in the ice section, we feel a sensation of coldness. Okay, and the agent which is responsible for that is heat, that is flow of heat. And here the direction of flow of heat, that is very important. So when we stand near the fire, the excessive heat from the fire, it flows towards us, that is the human body, which is at a deficit, okay, lower heat deficit. And as a result of this heat flow from the fire to the human body, we feel warm. The reverse happens when we put our hand in the refrigerator. There is a deficit of heat inside the refrigerator, in the ice tray or whatever. So as a result, the excessive heat from our body, it flows towards the refrigerator, towards the ice. And when our body, it loses heat, it produces a sensation of coolness and we feel cool. Okay, so why does this heat, it flows in one direction in case of ice and in the other direction in case of fire? We have to understand that. So in order to answer this question, there are two theories, okay, which try to understand, which to explain the whole concept of heat flow. First one is the caloric theory of heat, and the second one is the dynamic theory of heat. So according to the caloric theory of heat, it is an invisible, odorless, that is without smell, and we cannot see it, and it is weightless fluid, and the name of that fluid is caloric. So when some caloric, that is this invisible, weightless and odorless fluid, is added to a body, its temperature rises, and when it is removed from the body, its temperature falls. Okay, so in case of the first, according to the caloric theory, in case of this first case, okay, caloric is added from the fire to the body, human body, and as a result its temperature increased and we experienced a sensation of hotness. And in the second case, caloric is added from the hand to the ice, and as there is loss of caloric, so we experienced a sensation of coldness. But there is one major drawback, okay, to this whole thing. That is, we know that when we rub our hands together vigorously, we feel warm. In winters, in order to give us some sensation of warmth, we rub our hands vigorously and we place it on our face or any part of the body. So there is generation of heat because of friction. So the caloric theory, there is no fluid here that we experience or anything like that. So the caloric theory, it failed to explain this phenomena, that is generation of heat by friction. So it was replaced by another theory, a better theory, which is called as the dynamic theory of heat. Okay, so what is the dynamic theory? So according to this theory, all substances, all matter, whatever it is, they are all materials, they are made of molecules, atoms and molecules. And these molecules, they are always in a state of continuous random motion. Okay, they are always in a state of continuous random motion. And this motion, it can be categorized into three main categories. Okay, translatory motion, vibratory motion and rotatory motion. So let us discuss them one by one. Translatory motion is motion in a straight line. Okay, let's say this is the translatory motion. So here the molecule is there, let's say it is at the origin, and these are the three axes, okay, x, y and z. So it can move along the x axis, it can move along the y axis, or it can move along the z axis. Similarly, it can move along the negative x axis, negative y axis, negative z axis. But the motion is restricted to one line, in one direction. Okay, likewise it can also move in this direction, a straight line in between like this. Okay, it will keep moving in this direction, okay, like this, or it can move in a straight line in this direction, okay, only in one dimension. Likewise it can also move in this direction. I introduced the axis thing so that you can get a better picture. So its motion is restricted only in one direction, okay, this in a straight line, that is translatory motion, and it is common in gases. Then we have is the vibratory motion. So the vibratory motion, it is kind of simple harmonic motion, to and fro motion like this. Okay, so this is the mean position, let's say this is the mean position, and from this mean position these molecules, they can move up to two extreme positions, extreme points. Okay, this is the mean position and these are the extreme points, the negative extreme point, let's say on the left hand side, and another extreme point on the other side. So from the mean position they move to these extreme points and again back to the mean position. This is called as vibratory motion. Okay, this is vibratory motion. Then we have is the rotatory motion. So it is the rotation of molecules about a certain axis. Okay, so the vibratory motion, it happens commonly in liquids and gases, And the rotatory motion, it also occurs mostly in gases and usually at high temperature. Okay, so the rotatory motion is something like this. Let us say we have a molecule, let's say initially in this position, this is x-axis, okay, and let's say this is z-axis and this is y-axis. So the molecule is initially on the positive x-axis, so it rotates to the negative x-axis, and this rotation happens along the z-axis. It happens along the z-axis. It moves from positive x-axis to negative x-axis. Similarly, another case, let's say this is let's say this is y, this is x-axis, and this is z-axis. I'm just assuming, you can rotate this whole axis in any direction and you can assume any axis as anything. So there is no fixed hard and fast rule that only this side has to be taken x, only that has to be taken y, and that is z. So don't get confused, okay? So here we have just changed the orientation, okay? So here the molecule is initially on the positive z-axis, so it moves to the negative z-axis, and this rotation, it happens along the x-axis. Okay, from positive z-axis to negative z-axis, and this rotation happens along x-axis. So this is the rotatory motion. So we have the random motion of molecules, which can be categorized into three sections, that is the translatory motion, vibratory motion, and rotatory motion. So when a body is heated, okay, these molecular motions, they become very fast, vigorous, and as a result their velocity increases, and as a result of the increase in velocity, the kinetic energy of each molecule, because of each type of motion, that increases, that is translatory, rotatory, and vibratory. So this heat, okay, this heat which we say, it is this sum of kinetic energies of molecules because of translatory motion, vibratory motion, and rotatory motion. The sum total of the kinetic energies because of these three types of motions, that is called as heat, and it is called as internal energy. Okay, internal energy. So the important thing here is the concept of internal energy of a body, that contributes to the flow of heat. That is very important to understand. Okay, so here the thing to understand here is heat is the energy in transit, energy in flow from one body to another. When energy flows from one body to another, we call that heat flow. Heat of a body, the concept in itself is not right, because internal energy contributes to heat flow. We can say that a body has high internal energy or low internal energy, but we cannot say that a body has high value of heat, low value of heat. Okay, we generally say the body has high, that kind of a thing, but that concept is not right. We can say that a body has high value of internal energy or low value of internal energy. So when a part of this internal energy is transferred from one body to another, we call that heat. Heat is energy in flow or internal energy in transit, in flow from one body to another. So what decides that heat will flow from one body to another. We cannot measure, how can we measure this internal energy? How can we say that this body has high internal energy and this body has low internal energy? So for that, we have another parameter which is called as temperature. Okay, which is called as temperature. So we'll discuss that in a separate video in detail. For now, you understand that heat, let me use a clean side. Okay, let us say we have two bodies. Okay, this is one body, and let me use a different ink, and this is another body. This is body A and this is body B. Let's say these bodies are brought in contact, or they are just close by. There is no need of any physical contact for this, but there are various methods of heat transfer. We'll discuss that in the future videos, but now let's say they are in contact. Let's say the internal energy of body A is represented by U subscript A, and the internal energy of body B is represented by U subscript B. Here UA is greater than UB. Internal energy is the sum total of kinetic energies because of translatory motion, vibratory motion and rotatory motion. Okay, so as internal energy is greater than internal energy of body A is greater than internal energy of body B, so naturally temperature of body A will be greater than that of body B. So as a result, heat will flow from body A to body B. The direction of heat flow will be from body A to body B. So this flow of energy, this flow of internal energy, that is called as heat. Only when internal energy flows, there is a transfer of internal energy from one body to another because of its temperature difference. Why temperature difference happens? High internal energy contributes to high temperature. Low internal energy contributes to low temperature. Okay, that. So when a body has high internal energy, it will have high temperature, and as a result, energy, that internal energy, will flow from that body to another body of low internal energy and low temperature. And only that flow of internal energy is called as heat. Only that flow. Heat of a body is not a right thing to say. We cannot say that body has high value of heat energy or that body has high value of heat. No, only energy in transit, internal energy in which is being transferred from one body to another, that is called as heat. Okay, heat energy of a body in itself in isolation, that is not the right thing to say. Always remember that. Okay, so this is heat, which is energy in transit. So we can define heat as the energy in transit that flows from one body to another due to its temperature difference. And once the heat is transferred to a body, it becomes a part of its internal energy. So when energy is transferred, the internal energy to the body to which it is being transferred, that rises. Okay, here internal energy of body A, it goes down, and internal energy of body B, it goes up, and as a result temperature also goes down of body A, and temperature of B, it goes high. Okay, and another important thing, which is the unit of heat. So there are two units, SI units. The unit of heat is joule, it is measured in joules, and in CGS unit it is calorie. And here 1 calorie is equal to 4.186 joule. That is another important conversion thing which we can remember. Okay, so here we have discussed some basic introductory concepts on heat. Okay, from what is the basic, the heat flow, what determines the heat flow, and what are some theories on the concept of heat, and the most important theory, which is the dynamic theory of heat, which is basically molecular motion leading to change in internal energy, change in temperature, and causing flow of heat. Okay, so I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.